So I set you a few questions on compound angles in my previous video. What I'm going to do in this one is I'm going to work these through, show you the solutions, show you the general steps that you should follow to get them, and see how you go on from there. Quick refresher for you though as to what the questions were. First one was expand a couple of expressions using the compound angle formula. Second one, calculating the exact value of cos 15. Again, I gave you the hint that this could be done using the compound angle formula. And then the third one was using compound angles to prove an expression. So let's have a crack at these. First one, cos of x plus 30. So we have to expand these using our cos of a plus b, cos of a minus b, sin of a plus b, and sin of a minus b expressions. Now, cos of x plus 30 is the same as a cos of a plus b1. So remember for that, it's cos a cos b minus sin a sin b. So in this case, that would be cos x times cos 30, take away sin x times sin 30. Now the cos 30 and the sin 30, we can actually calculate those as exact values. Think of your exact value triangles. We are able to get them from that. Cos 30 is the equivalent of root 3 over 2, so that gives me root 3 over 2 cos x. And sin 30 gives me a half, so that then becomes a half sin x for the second part of it. And that's me got my expanded version of cos of x plus 30. That's all we need to get to for that one. I then look at my second part now, so sin of x minus 45. Remember that the expanded version of sin of a minus b was sin a cos b, take away cos a sin b. So we have to make sure we get that right. This time the minus goes with it in the expanded version, unlike up here where it's the opposite. So for this one, that gives me sin x times cos 45, take away cos x times sin of 45. I then need to figure out the exact values for sin and cos of 45 and then plug it all together. Well, sin 45 and cos 45 both give me 1 over root 2. So that gives me 1 over root 2 sin x minus 1 over root 2 cos x. As they've got 1 over root 2, I could take that as a common factor if I wanted and have 1 over root 2 bracket sin x minus cos x. Just as a slightly different way to write it if I wanted to, but it all means the same thing. So we've expanded those, we've got what we want for that. Next question was calculate the exact value of cos 15. Now when it asks for something like that, we have to think of the exact values in terms of the ones we know. Now we know 0, 30, 45, 60 and 90. We know the exact values of those. There's bound to be some way I can write 15 in terms of that. Well, 15 degrees is the equivalent of 60 take away 45 degrees. So what I can then do is say, fine, so cos 15, I can write that as cos of 60 minus 45. Now if I do that, I can use my cos expansion, so my compound angle formula for cos of a minus b, and expand that and then work it from there. Because this will allow me to say that that's the equivalent of cos 60 times cos 45 plus sin 60 times sin of 45. I can expand it doing that. Then I can use my exact values for each of these and figure it out from there. So cos 60 gives me a half, sin of 45 is 1 over root 2, so that's a half times 1 over root 2, plus sin of 60 is root 3 over 2, times sin 45, 1 over root 2. So that gives me 1 over 2 root 2, plus root 3 over 2 root 2, combine the whole thing into one fraction, and I get 1 plus root 3, all divided by 2 root 2. That's me got the exact value of cos of 15 degrees. I can do it using this. Think of these sort of questions in terms of the angles we know and we're able to use. Can I write it in that format? Final question. Prove sin of a plus b plus sin of a minus b equals this. Now a question like this, don't assume that they're right. What you have to do for a question like this is take one side, ignore the other, and manipulate it to get to the other. So for this one, what I would do is I'd take the left-hand side here, manipulate it and expand it using my compound angles, and look to get to this one before I even assume that that's right. So what I'd say is fine. So my left-hand side, let's start with that. Sin of a plus b plus sine of A minus B. So I've got different compound angle expansions I can use for both of these. Sine of A plus B gives me sine A cos B plus cos A sine B. And then my sine of A minus B gives me sine A cos B again. This time though it's minus cos A sine B. Now I can look to simplify this whole thing. I've got a sine A cos B and a sine A cos B. So that's then equal to 2 sine A cos B. I've also then got a plus cos A sine B and a minus cos A sine B, so they cancel out. So what I'm left with is that's equal to 2 sine A cos B. Well, lo and behold, that's there. So I then know that that equals the right hand side. So that equals RHS. So then I can state, therefore, sine of A plus B plus sine of A minus B equals what I want. It equals 2 sine A cos B. I've proven what it's asked me to prove, and I've shown what we're after. Remember with these ones, don't ever assume it's true. You have to prove it with your manipulation and your mathematics. Hope they went well. I will see you all back in class.